Hi everyone. So I missed the group meeting yesterday. So right now I'll be just making my video, which is chapter 1 and chapter 2, describing the statistics, the introduction, and also different kind of table charts, such as like the frequency table, bar chart, and the pie chart also. And then I'll add my video to the with the video that was created yesterday by everyone. So at first of all, it's the definition of statistics. Statistics refers to the numerical information, which is also the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decision. So yeah, and also statistics is like used in a lot of almost every sector of like big businesses and all those. Mainly it's used for the decision making process, and also the manager can take better decision when they have uh, statistical data in front of them. So how to describe data? There are a lot of ways to describe data. So in chapter 2, it has been talked about the frequency table, which is a group of collective data into uh, mutually exclusive classes, showing the number of observations in each class. And from the frequency table, you can develop a lot of chart, like bar chart, which is like really important. And that is a graph that shows qualitative classes on the horizontal axis and the class frequencies on the vertical axis. The class frequencies are proportional to the heights of the bars. And most importantly, the pie chart is really interesting and mostly used by mm, like businesses and managers than other charts like the bar charts and all those. So pie chart is the chart that shows the proportion or the percentage that each class represents of the total number of frequencies. So yeah, those are things that has been discussed in the textbook of in chapter 1 and chapter 2. So yeah, thank you everyone.
Welcome to our Applied Statistics Learning Engagement number 8, where everybody tonight is going to be talking about their favorite topics. So we'll be starting with Flavia for describing data using numerical measurements. Then we have both Hakeem Kunbi and Omar who will be talking about discrete probability distributions, and we will move on from there. So it's up to over to Flavia. Take it away. It's all yours.
Thank you. Get my screen. Are you guys? And here we go. So I'm going to talk about numerical measures to describe data. And the outcome of this is how to calculate the mean, median, and mode, explain the characteristics, use advantages and disadvantages of each measure of location, and compute and interpret range, percentile, variation, and standard deviation. What do we get out of numerical measures? And measures are used to summarize data, define if data is qualitative or quantitative. Quantitative data can be discrete when the possible result is finite or countable infinite number, or continuous. It's the result of measurements and maybe a percentage or a fraction using the same instrument. If manually calculating data, we must know that what the symbols in the equations are. So we have mu, we have n, we have x, sigma, sigma x, s, and so on. Once we have that, we need to focus on commonly used numerical measures for quantitative data that is divided in central tendency and variation. In central tendency, we have the mean, median, and mode. In variation, we have range, percentile, variation, standard deviation are the most commonly used ones, but we also have the coefficient of variation. The mean is the average of computed by adding all data values for a variable and dividing the sum by the number of data values. It is needed descriptive numbers like range, interquartile range, variance, and standard deviation to measure to describe data. The median is the middle observation. Oops, I'm sorry. The median is the middle observation of a set of observations. It's right in the middle point. Can be in increasing or decreasing order. The mode of the data is the data value that occurs with most frequency. The range is the difference between the largest and the smallest observation. Percentile provides an indication of how the data values are spread over the interval, from the smallest to the largest. They are divided in 4 parts. So we have the first, second, third, and fourth quartiles. And the first is 25, 50, 75, and 100. Variance measures the variability that are based on all the data. Population variance is the sum of the square difference between each observation. Then we have standard deviation. It's the square root of variance and most commonly used measure of variability. It measures the average distance of all data points from the mean and can never be negative. When we talk about standard deviation, we must talk about outliers. Is one of more values that are too large or too small compared with the other values of data. The mean and standard deviations are used to identify outliers. And with that, we get the z-score that represents the relative position of the data value by indicating the number of standard deviations it is from the mean. So the rule is any value with z-score less than -3 or greater than 3 should be considered an outlier. And then we have the coefficient of variation, which measures the relative variation with a data set. It's used to compare risks when the means are different, and they express the standard deviation as a percentage of the mean. Thank you.
Okay, so
Okay. Kinkumi, take it away.
yeah, so I'll be discussing variables. I mean, the discrete probability distribution, and just like we've been told about variables, we don't need to talk about that as business, scientific, and computational professionals. We all know that variables are represented by letters, and they kind of represent either quantitative or qualitative elements. But in this case, we're going to be injecting elements of probability, and that makes it to become a probability distribution. And so if we have different kinds of variables, and we put all of them in one basket, if we inject, like I said, elements of distribution, which we're going to talk about, not the nominal elements, but the probability elements, it becomes a probability distribution. And in this case, we won't be discussing that of continuous, which we all should know about, but we'll be discussing discrete, the discrete variables. So we have, so let's say I was able to, oh, sorry, let me put this slide. I was able to look at the census for 2020, for 2010, United States population, and for households which are, I mean, for, as an hypothetical example, households which have 1, 2, 3, 4, 5, n sizes of households have different probabilities. And in this case, X is used to represent them, as we know. So I was able to create a histogram graphical representation of what they are. And it, we also have the probability distribution function. And there's so many functions, just like all the statistical functions that apply to the nominal statistics also apply to the probability distribution as well. So I was able, we have the mean for the probability distribution, we have the variance, and we have the standard deviation. In this case, each of these characteristics is multiplied by the probability distribution of the variable. So let's give an example. So just like I said, I was able to make definitions. These are all definitions, but we are now going to consider the 7 elements, the 7 categories. The probability distribution is 0.267, 0. That's the second row anyway. Because of time, I won't be able to talk about that. If we're going to look for the mean of the probability, the mean of the probability distribution, we'll multiply the variable by the probability distribution, and we're able to get the third row. If you add the probability, one thing to notice, if you add all the probability distribution, it makes 1, which is 100%. So I was able to get the probability, the mean of probability distribution. And the answer say is 2.518. So the interpretation of that is that every household is expected to have 2.518 people in it. And of course, there's nothing like 2.518 person. So the interpretation states that it's either from 2 to 3 persons, but it's tending towards 3 persons because it's above the 2 value. I was able to get the variance as well. The variance is also the nominal variance multiplied by the probability distribution, as well as the standard deviation of the probability distribution. Thank you.
Omar, take it away. You can share your screen.
Akin, you have to stop sharing first.
Yeah. I'm trying to.
Thank you.
Can you stop the sharing?
Have I stopped the sharing?
You don't.
Not yet.
Screen is off. Okay, you know what? I'm gonna leave right
On the top of your screen, there's a red button that says stop sharing.
I can't find it.
You can
Eric
leave.
can also do it.
You can leave
Eric,
and you can rejoin it as well.
Maximize your screen.